Hi stakeholders, it's good to be here with you today, presenting on the topic of exploring meat consumption around the world. So let's get started. So first I'm going to tell you a little bit about the data set I worked with. It was a combination of life expectancy data from the United Nations, as well as global meat consumption data from the Organization for Economic Cooperation and Development, or OECD. So the life expectancy data is presented as life expectancy at birth in years, and the meat consumption data is given as kilograms consumed per capita in a year. The meat consumption data is divided into four categories of sheep, beef, poultry, and pig. So the two data sets that I worked with included data from the years 1990 to 2017 for 43 different countries. Right. So the life expectancy data that we're working with is very representative. As you can see in this chart, the Human Development Index, which is an index by the United Nations, rank for these countries ranks from um, the most developed countries in the world to the least developed countries. Also, by looking at this chart, you can see that there is a very strong negative correlation between life expectancy and human development. Okay, so the use case. So uh, I was trying to see if there's a link between meat consumption and life expectancy first, and secondly, I was trying to see if it is possible to distinguish different geographic regions by looking at their patterns of meat consumption. All right, so the results. First off, just by plotting, you can see that meat consumption correlates positively with life expectancy. As you'd expect, as people that eating meat helps people live longer, and also people who have more disposable income or more income in general could afford to eat more meat. So there is definitely not unexpected to see a positive correlation. As you can see, that correlation is flattening out quite a bit as life expectancy gets above 70 years old. But as you'll see, even though it flattens, you don't see it decreasing anywhere. So no evidence that life expectancy is decreasing because of eating too much meat, per se. So then I looked at, I just took that data and only took the points where life expectancy was greater than or equal to 75. Here you can see the positive correlation is almost non-existent, almost a flat, no correlation. So we kind of see two clusters in this data, one that's 78 and below life expectancy and one that's 80 and above life expectancy. Um, as it turns out, the countries in the top clusters are some of the most developed countries in the world, like top 10, top 20 on Human Development Index. And while the ones that are in the bottom cluster are not. So as you can see, um, yeah, there are some countries that eat a lot of meat, and they also have a very high life expectancy, and that seems to relate to being some of the most developed countries in the world. But as you can see, it's still a slightly positive correlation, no negative correlation. Okay, so then if we could establish that eating meat seems to be associated with higher life expectancy, maybe if we split meat up into categories, we'd see different results. So let's check that out. Okay, sheep data is kind of tough to work with because it's just not eaten in high quantities, but looking at this data, you can see there's no correlation between sheep consumption and life expectancy. Pig has a strong positive correlation, as you can see, which might be surprising considering it's a very fatty cut of meat, but yeah, fairly strong correlation regardless. Beef has a positive correlation, sort of flattens out faster than pig does, but still a positive correlation. And poultry also shows a very strong correlation, positive correlation between poultry consumption and life expectancy. So as you can see, even when splitting up between different kinds of meat, there's no change in our result. So the conclusion is, although there are confounding variables, meat consumption is associated with higher wealth, better health care, and better quality of life, there seems to be no evidence that eating more meat leads to shorter life expectancy. So it's not conclusive. Like I said, there's confounding variables, but based on what I've seen, I could definitely not say that eating meat could lower your life expectancy. Okay, so for the next part, I use some machine learning um, modeling on this data. So yeah, will utilizing machine learning give us new insights? So the first type of machine learning model I made is called a linear regression model. So a linear regression tries to draw a straight line that will kind of fit through all the data points and show a trend. I created this linear regression model to predict life expectancies in the country when the model is fed information of meat consumption, some geographic data, and development status data. And so my results of the linear regression were that the model had an average root mean squared error of 4.67. So what this means is that my model was about 5 years off on average on its predictions. So for something like life expectancy, a difference between a life expectancy of 75 and 70 is very significant. So I consider that this model did not do a very good job. So what this indicates to me is that it is hard to predict life expectancy simply by using meat consumption data and even some other key geographic indicators. It's really much more complicated than that. All right, so for the second model I made was to see if I could predict the region a country was in, geographic region, based on its food consumption pattern. So my data was divided into 5 regions: Africa, the Americas, Asia, Europe, and Oceania. And so I created a decision tree classifier to predict the region based on the meat consumption. Now, while for my, to this point, I was just using raw kilograms per capita meat consumption numbers. For this model, I tried a different approach of instead using proportions, like what proportion of total meat consumption was, say, poultry or beef for a country. I thought by doing it this way, I would kind of put rich and poor countries on an equal footing. So while one country might eat a lot less than the other country overall, the kind of proportion of different meats might be similar to a richer country. All right, so my results. My classifier had an F1 score of 0.9. The highest possible F1 score is 1.0, so 0.9 is a nearly perfect score. This F1 score means that my classifier was extremely good at classifying countries to the correct regions, the correct geographic region they were in. And what this result shows is that geographic regions are very much distinguishable by having unique meat consumption patterns. Like if you live in Africa or Asia, the proportions of what meats constitute your meat consumption are going to be very different. All right, and finally, I created an online application. So this online applications let anyone interact with that classification model I made. So what my online application does is that it will guess what geographic region you live in when you tell it your meat consumption pattern. And you can try out my application at the website below. So thank you so much for listening, shareholders, and I hope I brought you information that will be useful to you. All right, thank you. All right, hello data scientist peers. It's good to be presenting to you today about the methodology for the creation of my report that was exploring meat consumption around the world. So first of all, my data source was my data came from 2 sources. One was the United Nations Development Program Human Development Reports, and one was the Organization for Economic Cooperation and Development meat consumption data. Like I said, open data CSV format. I uploaded these CSV files to Watson Studio, where I could access them as Spark data frames. Okay, so data integration. I used Apache Spark from within Jupyter Notebooks. It is easy to load CSV files as Spark data frames, and also it is easy to access and manipulate data in a Spark data frame by using SQL queries. Data repository. I use IBM Object Store. My dataset was only a few CSV files, so it was suitable to store them in Object Store. Object Store also integrates with Watson Studio, so it's easy to access my files. Okay, so data preprocessing for the United Nations data preprocessing was fairly simple, trimming white space in columns, removing blank columns. The OECD data was a little bit trickier. I had to remove future projected. The data set included data that was not actual data but projections data, so anything with a year above 2018 I removed. I only wanted measurements that were in kilograms per person of meat consumption. I didn't want the data that was in how much thousands of tons the whole country consumes. So I got rid of all that aggregate data. So the data was split up. Each meat type had its own row, but for convenience, I wanted every meat to be in the same row for a given year for a given country. So I had to do that. Also, for some countries, Norway and Switzerland, I believe, didn't have data in a kilogram per person. So I had to just take the data that was for the whole country, then look up the population data for those two countries and calculate kilograms per person manually. The final step was to join the data. So I joined that United Nations data with the OECD meat consumption data on country and year. The slight issue was that the United Nations data had country names and the OECD data had just abbreviations. So I figured out the format was the international format, ISO Alpha 3 abbreviations. So the UN actually has a CSV file, which is a key, taking country names to abbreviations. So essentially it was a join on 3 separate data frames that allowed me to combine the UN and the meat data. Okay, feature engineering. So I noticed early in my explorations that Human Development Index rank was highly correlated with life expectancy. So, I had to drop that column when I was predicting life expectancy. Otherwise, it would be too simple to predict. Sometimes I use individual meat types. The meat types were pig, sheep, beef, poultry. Sometimes I add it up. I just use meat total as a feature. For my main model, actually, my classification model, I used the proportion of each meat was of total meat consumption as features rather than the raw meat consumption amount. I also used PCA, my dimension reduction didn't really work too well. Min-max normalization, most of the time my models worked fine without normalization, didn't need it. In the case of proportional data, it already is normalized, so that's another thing. Okay, discovery and exploration. I use Jupyter Notebooks for creating visualizations and calculating metrics. I just created simple, chart scatter plots, primarily with matplotlib and Python. Didn't have a lot of variables, so mostly, two-dimensional charts are okay. For calculating metrics, I used MLlib, the Apache Spark, in Python. The MLlib statistics class, you could easily calculate correlations between RDDs. Okay, actionable insights. I used Python, Apache Script, and Spark ML. I already had my data as a Spark data frame, so my pre-processing was on the Spark. Spark ML is an easy-to-use pipeline format, and it also, out of the box, supports many machine learning models. I created a linear regression model and a random forest classifier model. So my first model was a linear regression model, looking at how well all my other data points minus HDI rank could predict life expectancy. And I used regression in this case because life expectancy has, a continuous range, starting in the 50s to the 80s. And then for my second task, I used the random forest classifier to predict what geographic region the country was in based on the meat consumption patterns of that country. So first I tried standard decision trees. It was giving me, okay scores of like 70 or 60% accuracy. And once I tried random forest, it got me up to like the 80s or even the 90s in accuracy and other metrics. Okay, model evaluation. So to evaluate my linear regression, I used root mean squared error because that basically tells you what the average error is for each prediction. Is the error between your prediction and the actual data point. So considering I had this pretty high RMSE of about 4.7, which for my data seemed pretty high, I knew the regression model was not exactly working that well. And I used that inside of my report. I used F1 score to evaluate my random forest classifier. So as you know, F1 score is the harmonic mean of precision and recall. So since I had an F1 score of 0.9, that means that my classifier was doing really well both on precision and recall, meaning it was getting countries in the right category, picking the right region for countries at a very high rate. Okay, application and data products. So I conveyed my findings to the Jupyter Notebook, exported to PDF. Jupyter Notebook allowed me to show a step-by-step procedure of how I got my results and also allowed me to include a lot of charts. And finally, I created a web application that interacted with my random forest classifier. So this allowed anyone to kind of using their own data from their own personal experience, interact with that random forest classifier and see how it works for themselves. All right, thank you, peers, for watching, and I hope you learned something from this presentation. Thanks. Okay, finally, I want to show you guys what my application looks like. You can check it out yourself at geocaveldze.buyithost7.com/watson.html. So I simply ask what your meat consumption looks like, so you can fill in. Like for me, I eat, let's say, mostly poultry. I don't eat much beef or sheep. I'll put a little bit for beef, a little bit for sheep. Not really, not much. Other meats, I eat fish. So I think this is a good, maybe a little bit more for poultry. This is kind of a good breakdown of how much meat I eat. So I submit it, and then it loads, and it says, I think you're from Asia, 74% sure. And then second pick, Americas. I actually live in the Americas, so at least it got me right on the second pick. So yeah, when I push submit, it sends this data over to my random forest classifier, and yeah, it tries to predict where I live. So you can try this out for yourself and see if it works for you. All right, thanks.